All right, with these types of molecules, it's extremely important to understand not only how that they share the electrons most of the time, for covalent they always do, but it's also important to understand how they share them. Okay, and that's where bond polarity comes in. Bond polarity measures how two electrons are shared, or how electrons are shared between two elements. And what's true about everything is it's not always shared equally. So pretend like you and your sibling are sharing a car. You may get it 90% of the time and they get it 10%. So technically you're sharing, but is it equal? No. And how do you determine for a bond how these electrons are being shared, whether it's equally or unequally? And what it does is it depends on the electronegativity value of that element. And remember from first semester, electronegativity is the ability of an atom to attract electrons to itself when shared in a bond. And F is the most electronegative, Cs or cesium is the least electronegative. So what that means is F will want the electrons more than any other element, and Cs will want it as little as possible. So there are three types of bonds that you're going to have to understand, and these are between just two individual atoms. The first is nonpolar covalent. So the word covalent means that it is shared, and nonpolar, what I always think of is no pull. So there's no pull in a given direction of these electrons. So what that means is that the electrons are shared equally between two atoms. So a nonpolar is there's no pull of electrons going particularly towards one element versus another. And how do you determine if it's going to be nonpolar covalent, so meaning shared but equally, is that their electronegativity difference is less than 0.4, equal to or less than 0.4. A polar covalent bond means that the electrons are also shared, but they are shared unequally. And so for this one of the elements has a greater attraction for electrons than the other one. How do you determine whether it's going to be polar covalent versus nonpolar covalent? Is that the electronegativity difference between the two elements is between 0.4 and 2.1. Okay? And ionic bonds. In ionic bonds is actually notice that it's not covalent, and that's where it's basically entirely given or taken of the electrons. So where the electrons are 100% transferred. So in this case, in this drawing, sodium 100% gives up its valence electron. And how do you identify those? Their electronegativity difference is greater than 2.1. or equal to. When you look at these pictures on the right, what you should notice is that these are basically like the electron clouds, this outside. And if you notice here in the first one, it looks like it's perfectly distributed evenly. If we look at the next one, if you notice it's heavier on the right hand side. That means even though they're sharing these two electrons, more of the electrons are spending more of their time on that chlorine than on that hydrogen, which means that that chlorine wants those electrons more than that hydrogen does, which means that it is a higher electronegativity value. What you should also notice is that sometimes you can write that delta, it's a lowercase delta negative and a delta positive, which means that there's a partial positive on this side and a partial negative on that side. And the reason why is even though they are sharing these electrons, more electrons have shifted towards the right-hand side, and therefore it is a little bit heavier on the chlorine side or on the right-hand side than on the left. So therefore it has a slight negative pull towards the right. For this ionic bond, you'll notice that it had that arrow drawn there, and what that's showing is that that electron is entirely being given to that chlorine in that open spot. So this is an ionic bond. Now these ranges that we're giving you right here, it's kind of like, it's iffy. You know, it's kind of like up to the scientist, the chemist to say, oh, these are going to be considered nonpolar, these are going to be considered polar. Some teachers teach that, hey, if there's any difference, it's technically polar. Some teachers teach that it's even up to 0.5 is considered nonpolar. And what it is it's kind of like, I guess, the scenario of you sharing your car with your sibling. If you're sharing your car with your sibling, you may have it 60% of the time and they may have it 40, and your parents are like, well, that's totally equal. Whereas your sibling may say, hey now, that is not equal in any sense. So it kind of goes like that with the ranges, but these are the ranges that we're going to keep in this class is 0.4 to 2.1. All right, so electronegativity and bond polarity. So all you have to do is take the difference between the two electronegativity values, and that's how you determine whether it's nonpolar, polar, or ionic. So for example, F2. So what you're going to be doing is taking the electronegativity value, which is 4, you're going to subtract it from 4, and you get a difference of 0. This is considered not only nonpolar, but completely nonpolar, which means that they are 100% identical in how much they share. HF. So H's value is 2.1, F's value is 4.0, so your difference is 1.9. That falls under the polar covalent range. And then if you look at NaCl, we've got a difference of 3 to 0.9, which is a difference of 2.1, which makes it ionic. So all you have to do is go through those ranges of 0.4, to, I don't think it's equal to X, and then to 2.1, which means that these guys, anything that falls under here is going to be considered polar. If it's over on this side as a Y, then these would be considered nonpolar, and I'm going to abbreviate as P and NP, and anything greater than 2.1 is considered ionic. And this is for, once again, how these electrons are being shared in between bonds. How do you show this? As I've already talked about, you can show that there is a delta negative and a delta positive. What this shows is that the electrons are heavier on the F, so therefore I know that F is more electronegative than H. Okay, so that's one way without having to look at a chart. This is also another way is you draw an arrow going towards the more electronegative number. You always point the arrow towards the more electronegative number. And that shows that F, it is a polar bond, and that F is more electronegative than that H. All right, hopefully you have a basic understanding of the polar bonds. Remember that polar is an unequal sharing, nonpolar is perfectly equal sharing between two elements of electrons, and ionic is where one element basically gives up all of its electrons to the other element. Have a great evening.